Okay, now we're going to talk about the single most important technique of integration. By integration, I'm basically meaning finding antiderivatives, because as we've seen, if you want to do a definite integral, you just find the antiderivative and plug in at the endpoints. If you want to find an indefinite integral, you just find an antiderivative. So, integration by substitution, which is also sometimes called u-substitution, is the chain rule turned inside out. So what does the chain rule say? Chain rule says that if you've got a function, let's call it capital F of u, and u is some expression like 3x squared plus 7, then the derivative of that was f prime of u times the derivative of u. So if we let little f be the derivative of big F, and this says that the integral of little f of u du dx, well, little f of u du dx is the derivative of big F of u, so this integral just gives you big F of u. On the other hand, if we never mentioned x to begin with, if we just wrote integral of f of u du, we would also have gotten big F of u. So the idea of u-substitution is to try to rewrite things in terms of a new variable u, where du is du dx times dx. So that's the technique. Let's do some examples and see how it works. So our first example, we want to figure out the integral of 3 e to the 3x dx. In this case, we'll define u to be 3x. And then du is, well, the derivative of 3x is 3. So we get 3 dx, and we see that these two together make du, and then this term here is e to the u. So this becomes the integral of e to the u du. In the integral of e to the u du, we find a function whose derivative is e to the u. That's just e to the u plus a constant. And then we want to rewrite everything in terms of x, so we say that's e to the 3x plus a constant. And you can check. If you take the derivative of e to the 3x, you get 3e to the 3x. So this is an antiderivative to 3e to the 3x, and we're done. The indefinite integral of 3e to the 3x dx is e to the 3x plus a constant. Okay, here's another one, a bit more complicated. Let's take x e to the x squared dx. In this case, we want to pick u to be x squared. Then du becomes 2x dx. Now in the last example, we had du staring at us. Here we don't. Here we have x dx. We wanted 2x dx. That's easy. This is just du divided by 2. So this is the integral of e to the u du divided by 2. And that's easy. That's e to the u over 2 plus a constant. So that's e to the x squared, all divided by 2 plus a constant. Okay. Now, what if we didn't have that extra du term? What if we were looking at e to the x squared dx? If you try to do this with a u-substitution, say u equals x squared, you say, oh, this is e to the u, but this is not du. Du is 2x dx. You don't have a 2x dx, you have just a dx. It doesn't work, you're stuck. In order to do a u-substitution, you have to write part of the integrand as a function of u, and the remainder of the integrand, so here, this part is a function of u, and the remainder of the integrand has to be du. Okay, a couple more. First is the integral of 2x plus 1 dx. Here we'll let u be 2x plus 1. So du is twice dx. Well, dx is du over 2, so this becomes the integral of u to the 5th du divided by 2. That 2 doesn't give us any problems. This just becomes u to the 6th over 12, and that's 2x plus 1 to the 6th divided by 12. What about logs? In this case, it looks a little bad, but we notice that dx over x is the derivative of the natural log. So here, if we let u be the natural log of x, du is 1 over x dx, and voila, this is the integral of u du. That's u squared over 2 plus a constant. I should have said plus a constant over here. And that's natural log of x squared over 2 plus a constant. Last one, tangent of x. Got a perfectly nice trig function. That's the integral of sine of x over cosine of x dx. Okay. This is a little bit tricky, but you notice the derivative of cosine is sine, or minus sine actually. So if you let u be cosine of x, du is minus sine of x dx. This becomes the integral of minus du over u. So that's minus the natural log of the absolute value of u plus constant. So that's minus the natural log of the absolute value of the cosine of x plus a constant.